This conference will now be recorded.
Hello everyone, and welcome to this third seminar of the Ideal for OMOP training program. It's great to see some names I'm starting to get familiar with in the meeting today, and it's great that you could join us. So let's, if you could advance the slides please, James, let's talk a little bit about what's going to happen today. We're going to start with some just some brief introductions, and I'm going to recap, just to remind you where we are in the course at the moment. But the main show today is a deep dive onto some of the more technical aspects of study design in OMOP, and a chance for you to be introduced to some of the key tools that can really help that work very effectively. So we'll be talking about something called Atlas and something called Hades, which, if like me, you like Greek mythology, is very exciting. And then we'll just wrap up at the end, as we usually do, just to remind you what's coming next. And there'll be another quick chance, I hope, to tell you about the SharePoint. So in terms of introductions then, next slide, please. I think by now you'll be used to me. My name's James Anderson. I oversee the training programs at DIGICORE. James Brash, I think you'll be familiar with if you've attended some of the previous seminars we've had, and the introductory call we had over a month ago now, I think. Also really pleased today to welcome Jack, who is a colleague of James and works together at IQVIA with various of us who are involved in the program. So great to have Jack as well. They are both real experts in running studies in OMOP. And for some of you who might be familiar with the metastatic non-small cell lung cancer work that we've been doing in DIGICORE, they've been absolutely instrumental in helping drive that study forward. So real kind of experience from the front line, and really looking forward to hearing what they've got to say. And then again, another familiar face, we'll likely hear from Will at the end. So that's us. If you've not said hello in the chat, feel free to say hi. It's always nice to see your names in there. So I'm going to start quickly just by reminding ourselves where we are in the course. So if we could advance on to the next slide, please, James. I think by now, again, you'll be fairly familiar with this. We are very much in that stage there, the basic training, team formation, and scientific concept. So this is a bit where we start to introduce you to some of the key concepts and ideas around running studies in OMOP. And then as we get towards the summer, we're going to be helping you to form teams and start to work together in international teams based around particular tumour types. So you can start to think about what studies you might want to run and how you're going to go about applying for the funding that's available. So we're actually at the halfway stage of that now in terms of seminars. So this is the third seminar out of 6. And if we go on to the next slide, you'll see just exactly how that fits together. So these 6 seminars designed to give you a flavour of the different aspects of leading and running studies using OMOP. So we've had a couple already. So last week, you probably remember, we had Atif and Rosie talking about some of the epidemiological and kind of some of the features of study design from that point of view. Today, we're going to be dipping our toe in the water and looking at some of the technical tools that are available as well. In a couple of weeks' time, we've got a webinar on patient involvement, which I think is going to be really interesting, and something that I would encourage you all to think about what you might do in terms of that for the studies you'll be running. An important webinar in June on data privacy, and then finally we'll be giving you some guidance in terms of team formation. So a nice range of seminars. Obviously, they're only about an hour each, so there's only so much content that we can cover in each of them. And we certainly don't expect you to come away from all of them being complete experts in the field, having attended a 1-hour seminar. But what we do hope is it just gives you some flavour of the topic, an introduction to the key concepts, an interest to learn more. And if we go on to the next slide, I think it's really important to stress that the seminars are only one part of the support that you're going to be getting over the coming months as we go through this program. So obviously you can see the seminar program, that's where it kind of starts, those 6 seminars. Some of you, I think, are already on the SharePoint website. That also is a great resource. It has all the seminars, but it actually has lots of other material as well, different recordings, webinars, online resources, lots of different things that you can use to build your expertise and knowledge. So we'll say a bit more about that at the end, but if you're not on the SharePoint website yet, please let us know and do go in and have a look. There's also going to be the opportunity for you to get expert advice. Within DIGICORE, we've got, including some of the people who are presenting today, we've got some really good experience of running these kinds of studies, and we will be able to make those folk available to you to ask questions and help steer your study design. You'll remember also we have a leadership advisory board, very experienced and very, I guess, distinguished international experts on the leadership advisory board, and we're just in the process of setting up some time in September when you'll be able to come to them and start to share your emerging ideas and get some steer and feedback from them. And then, of course, you've got each other. You will be able to learn and grow with each other who, if not experts now, you are the experts of the future in running oncology research in OMOP. So this will be a great opportunity. And I think as much as anything else, the value of this course to you will come through the networks that you build and the relationships and friendships indeed that you make through the course of these studies. So over the coming weeks, we're going to be doing a little bit more kind of matchmaking and introducing you to people with common interests, particularly around particular research areas and particular tumor types. So watch out for that. But I guess my take-home message from this is, the seminars are a first step on the road. They will give you, as I say, a flavor. They will introduce you to some of the key concepts. But if you find that you don't remember all of it or some of it's a little bit woolly, do not worry. There's going to be plenty of other opportunities for you to build on this learning and cement your understanding. So I think just the last one then from me, the objectives for today. So one of the sort of messages that I'm learning about OMOP and the Odyssey community is that there is already so much out there that you can build on, you can use in the public domain. And Jack and James are going to be talking about two particular tools, Atlas and Hades, that fit those criteria and will in due course, I'm sure, be really useful to you. So we'll be looking at those. We'll be thinking about the practical applicability of those tools as well. And that's it from me. So James, if you'd be kind enough to take it away with Atlas. So I've got one last thing to mention, actually, sorry. As well as the PowerPoint slides, we will be looking online at some web pages. And if your eyesight is like mine, you might struggle to read it. But if you are on the web browser version of this, there is in fact a zoom in and a zoom out button. So if you hover your mouse over the screen that's being presented, you can actually zoom in and zoom out. So you might find yourself needing to do that. You might be absolutely fine. But if you're struggling to read it, just know that there is that quite nice option that you can use in this GoToMeeting platform. Right, that's it from me. Over to you, James.
Thank you very much, James. So after that great introduction, I'm just going to revisit what, if any of you were here for the first seminar, what I described as the 4 pillars of OMOP. So OMOP is all about standardization of healthcare data. And from that, we have the standardized common data model, which is the table structure by which we store our healthcare records. There's the standardized coding system, which ensures that clinical events are represented by the same code, regardless of what the source data is. And I said, because we have a standardized common data model and a standardized coding system, we can then build standardized quality assurance tools and also standardized analytical tools, because these tools anticipate the data to be in a certain format. And really, that's what Jack and I are going to show today, some of these tools. And the tool that I'm going to speak about is called Atlas. Anyone who has even vaguely been involved in OMOP will have heard of Atlas. It's a software for designing and executing research against an OMOP common data model. And I like to think of Atlas in 4 parts. First of all, there's data source exploration functionality. So you can use Atlas to essentially search through your databases to see what type of records you have and the nature of your data. Then there's functionalities for building concept sets, or as we call them, code lists, or as we call them, concept sets, and then integrating those code lists into cohort designs. And cohort definitions are the foundation of all of our research here, because they're effectively what we use to select patients from our databases to run our research against. Atlas also has a series of descriptive statistic tools. So within Atlas, you can run a cohort characterization, asking questions such as, what are the demographics of my cohort? What baseline medication is my cohort on? And what comorbidities does my cohort have? You can look at incidence rates. So for a cohort of interest, what is the incidence of an adverse event of interest? And you can also look at treatment pathways within Atlas as well. So the sequential order of treatments by which patients in your cohort got. In addition to these descriptive statistics, there are functionalities in Atlas as well for helping you to design population level estimation tools, so comparative effectiveness studies and comparative safety studies, and also for building patient level prediction models as well. I make a point about saying that Atlas has the design functionality for this because we don't actually run these in Atlas. We design it, export it, and then we run it from an R environment. And that's because R is Jack will go into this more, but R is the language of choice for the OMOP Odyssey community. So really today we're going to focus on the building, I'm going to focus on the building cohorts and a little bit about the descriptive statistics. So in OMOP, I've called this a feasibility pipeline because essentially we're building a cohort to decide whether we can go over study. This is effectively our pipeline here. So we go from a concept to a concept set, and then we apply logic to that concept set to build a cohort. So let's break that down a little bit more. So a concept is a record of a clinical event. So for instance, we could have the concept primary malignant neoplasm of prostate, and that's represented by the ID 200962. We can pull together multiple concepts to better describe a clinical topic of interest. So for instance, if I wanted a broader prostate cancer code list, I could also include these concepts for carcinoma of prostate, adenocarcinoma of prostate, and small cell carcinoma of prostate. The concept set is not a cohort. From our concept sets, we now need to apply logical criteria to it to define which patients we want to include in our study. So for instance here, I have a cohort of prostate cancer patients, which I say they must be over the age of 65 with a record of prostate cancer, and that would be referring back to my code list that I just described, between January 2010 and December 2020. So what I'm going to go through now is on Atlas, how this pipeline looks. I'm going to show you exactly how we build these code lists and the cohorts as well. So what you can see here now is Atlas. I'm going to zoom in slightly. And on the left, we have a series of tabs with different functionalities. So we have the data source tab, which I referred to earlier. This is our tool for effectively searching through our data, exploring the data. We have the concept sets tab for building code lists, the cohort definition tabs for building cohorts, and these are the 3 characterization tabs that I was just describing. So if I wanted to build a code list, let's say for instance, I build a code list for prostate cancer, I will tick this concept set box here, and I will give it a name. I will go to add concepts, and this is where I choose which codes I want to include in my concept list. Those of you who are at the first seminar will be familiar with the tool Athena. So Athena we can use for finding our codes of interest. So here I'm going to look for primary malignancy of prostate. Primary malignant neoplasm of prostate is the code that I want. I'm going to search this against my database. And I have here the code that I want, so I will click it and I go add to concept set. And now I have effectively a code for capturing this one prostate cancer code. Again, for those of you who came to the first seminar, you'd have heard me speak about the OMOP hierarchy, the idea that we don't want to just use one code, we want to use everything below that in the hierarchy to capture all granular codes as well. So here what I would do is I click Descendants, and as I click Descendants, you'll see that my code list is going to go from 1 to 165. So this is just a more encompassing code list. Okay. So typically at the beginning of any study, our first stage is to identify which cohorts we need to build and also which code lists that we need for them. And we will go through this process on Atlas, building out these concept sets. How we choose which codes that we will include is something we can go into in more depth at another time. But once we are done, we then want to navigate to the cohort definitions tab. So this is the interface for the cohort definitions tab. The first thing I'm going to point out is at the top, you've got these different tabs here. And under the concept sets, you can load up all the concept sets that you're going to use for your study. So here's the prostate cancer one that I just showed you. So slightly more here because I've chosen a slightly different higher up code. But I've also got code lists for PSA measurement, for those of you who are familiar with prostate cancer, for TNM staging as well. So here for TNM metastasis staging, TNM node staging, TNM tumor staging, so forth and so on. So I'd have built all of these concept sets, all of these code lists that I need to build out my cohort definition, and then I bring them into this functionality here. Within the functionality, within the cohort definitions functionality, there's 3 boxes that I'm particularly interested in. There's this top box, which is called the cohort entry event. And this is where I define the index event. What is the clinical event that occurs in order for patients to be eligible to enter my cohort? And that's going to be their timestamp for cohort start date. So any observations that we do for those patients will be linked to this index event. I can add additional criteria to the inclusion criteria. So I might say that I want my patients to be over the age of 60, they must be male, they must have a TNM staging of T2N1 M0, so forth and so on. So essentially, that's filtering down my list of patients. And then finally in Atlas, I want to define a cohort exit criteria. At what point do we no longer want to observe these patients? So for instance, in a cancer study, you might say that once they progress onto a second line of therapy, and you can define what that therapy is, you might say cohort exit on the switch to the therapy, or if they progressed, and so forth and so on. Essentially, that's where you're going to define that information here. Now, this is a really nice tool to use. It's very intuitive. Essentially, I'm just going to walk you through one of these. So the cohort entry event here. What I do is I go to add initial event, and I need to choose the table for which my initial event is related to. So these are the OMOP common data model tables. So we have conditions for any diagnosis, drugs obviously for any medication, measurements and so forth. Here I'm going to choose the add condition occurrence. And now is when I bring in my code list. So I've got a code list of prostate cancer here. And what I'm saying here is effectively, I want to capture any patients who have in the condition occurrence table one of these codes that I've used to define prostate cancer. I can add different criteria to this as well. So using this add attribute function over here, I have a lot of qualifying criteria that I can add. So I could say, for instance, that this condition start date must occur sometime between 2010 and 2020. I could require that the patient has to be a certain age at the index event, and so forth and so on. These two boxes here, essentially what I can say with this is that I'm specifying that the patient must be observed for a certain period of time before the index event. And the reason for that is often we want to make sure that we have a large enough window to characterize some baseline characteristics. And also if we have any exclusion criteria, we want a big enough window to capture that in as well. So here I could say, include patients that have prostate cancer and they must be observed in the database for at least 1 year before. And you just go on like this. You just go on to carry on building your criteria. So now I could go to my inclusion criteria and I could say that they must be on a certain drug, or I could say that they must have a measurement and then add in my TNM score here. So they must have a metastasis, and I can say that it's M0, so forth, so forth. And it's really just this checkbox exercises that helps you build out this code. So I'll show you what one looks like when it's complete. So this is a cohort I made before, prostate cancer locally advanced EAU high risk score. You can see the cohort condition occurrence of prostate cancer. I've defined here that the patients must have a T-score of T3 or T4 and a TNM end staging of N1. So a measurement of TNM tumor, a measurement of TNM node, N1. For metastasis, they must not have metastasis record on their staging, so a measurement of TNM metastasis where the result is M0. Just to point out here, so this is a time frame relevant to the index event. They must have a measurement of PSA greater or equal to 20, and it must be in nanograms per milliliter, again, within 6 months of the diagnosis, and then Gleason's score here. So you can build up these really nice, quite complicated cohorts in Atlas for your studies. And what Jack's going to show, and I'll show briefly, is you can take these cohorts and use them in your study design. And really what it's doing under the hood, it's just writing SQL, if you see here, which will be executed against your cohort, your database, your OMOP database. So if I was going to generate these in Atlas, what I would do, I'd click the generation tab here. Here I can see all of the databases, all of the OMOP databases that are connected to my Atlas instance, and I select one that I want to run against. So here at the bottom, it's slightly cut off, I'm afraid, but I've run this cohort definition against the IQVIA Oncology EMR database. I can view the reports here, and this is going to tell me how many patients satisfy my cohort criteria in this database. So what you have here, you have matches. And matches is saying that there's 151 patients that match my criteria. So I've got 151 patients I could use in my study. And then the total events actually refers to the index event. So essentially what this is from 171,000 patients, I have 150 I can include in my study. And then I see here the attrition of my cohort here and where patients were lost from the original index event here. So from the TNM staging, we come down to 566, so 5,520. PSA measurement, we go down to 566, and finally Gleason score, once we add that on, we only have 150 patients left. So again, what I'm emphasizing here is that this is the initial stage of the study. You define your cohorts and you define the code list you need for them. You can build those all up in Atlas, and then you've got a choice as to how you want to go forward with your study then. So this will enable you to select from either your or collaborators' OMOP databases, the patients that are eligible for the study. But then what you want to do with the analysis, there's several options. So what I'm going to show just very briefly before I hand over to my colleague, Jack, is how you can run some analysis in Atlas itself. So here we have the characterizations tab, and under this tab, I can take my cohort. So I've got my cohort here. I just import it into this tab here. And then I can import various features that I want to characterize my cohort by. Many of these features are inbuilt to Atlas. You don't have to code them in yourself, which is a really nice functionality. But Atlas does also allow you to code in features if there's some custom things that you want to study. So as you can see here, I'm going to characterize this cohort by the index year, the age of the patients, the race, the age group, drugs that we were using within the long-term window. So that's any drugs that the patients were using within a year of being diagnosed with prostate cancer, and any comorbidities that the patient was diagnosed with within a year of prostate cancer. These are all default features. And we don't have the time to go through it today, but there's around 100 default features that you can use in Atlas for your table 1 style characterization, if you will. But you can build these custom features. So here I've built characterization to characterize the prostate cancer staging, the average PSA score, the ECOG performance in categories, and also the Gleason score. And once you're done, you once again go to Executions tab over here. You choose the database you want to run this against. So here I've done OncoEMR. And once it's done, you can view the results. And so what I can go through here is the different results of my analysis. So I can see that the age breakdown, for instance, here, the age distribution. I can see the cancer staging, so that in this cohort, this is actually a global prostate cancer cohort, not the original one I showed. You can see that around 15% of them are metastatic, around 15% are localized, 2.5% are locally advanced, and for the remainder, I don't have information. Here I have a breakdown of the PSA score, and so forth, and so on. And there are other functionalities. So the incidence rates tool you can use for calculating the incidence of an adverse event or an event of interest in your cohort as well. And then on the cohort pathways, this is where you can really build out your treatment pathways, take in a sequential order of treatments for your cohort. So here, this is something I've worked closely with my friends over in the Pioneer community. We've got a cohort of prostate cancer patients, and whether they are taking an RC or an ADT. And essentially what I can do here is build out the treatment pattern that this cohort takes for those drugs. So if I show you this result now, it's a really nice little functionality, really simple to use. And you can just see that most of the cohort is on ADT, some of them are on ADT plus abiraterone, some are just on abiraterone, so forth and so on. And these are the different rings of the different treatment pathways. But really what I'm trying to get across is just that once we have those cohort definitions, we can then pump them into the various features of Atlas to run these analysis. But we're also not restricted to Atlas. And actually, when we do our network studies, such as a network on something like DIGICORE, we're really going to rely on some of the tools that Jack's about to introduce, where you can build our packages that integrate your cohorts. So with that, I'll ask if there's any questions on. Oh no, we'll do questions at the end, but I'll pass over to Jack at this point.
Actually, do you mind? Sorry, it's James here. Do you mind if I just had a very quick question?
It might be a natural part to have a question, yeah.
Yeah, I was just kind of trying to, well, I was following along on the screen, but I was also wondering where I could get this on the web. And I did Google it. It looks like you can get it just at odyssey.org. There's an Atlas demo. It is free, right? Ah, there we go. We've already got that in the chat. Thank you very much.
Thank you very much for dropping that in. So there is an Atlas demo, but that is only connected to synthetic data. So it's very good for exploring if you don't have your own database set up, but your sort of outputs will be limited.
And that was actually answers my second question, which is, given that I know some colleagues here have cancer data in a configured in an OMOP instance, but many others haven't yet. We're working on it. Certainly in the I3 sites looking to build towards that. Where can they get some data to play with? Is it just on the demo site? They've got some cancer data there. Is there, what is the nature of that synthetic data? I guess you can go in and play around, right?
You can go in and play around. It's not cancer specific, to be truthful. Okay. And to get the sort of cancer level data that you would want to run, sort of query, like even this cohort I built here with TNM, PSO, or Gleason, you're really going to need, I think, real oncology data for that. I'd be surprised if you found that in any synthetic data.
Okay. So
unless someone could take the initiative to generate that, though, and that would be great for the community.
Yeah. So people can maybe practice some of the high level concepts, but in order to get into the kind of the detail of exactly how you would do it in cancer, you probably need some of your own data to do that.
Yeah, but definitely jump on the Atlas demo to have a play around.
Okay, brilliant.
Okay,
okay, fine. Yeah, let's hand over to James. So Alex, if you could just switch the presenter around, that would be great. Yeah, you're on, Jack.
Thank you, James. I hope everyone can see what I'm sharing.
Yep.
Okay, so as As my colleague James alluded to, I'm Jack, and I'm here to talk to you today about Hades. Hades is the fantastically dramatic name that Odyssey has assigned to the collection of R packages and associated coding stack that we use every day. The Hades operation underpins a lot of what is achievable in Atlas. As James mentioned, a lot of the things in Atlas will produce things that can be taken out and moved into an R environment for execution. So Hades as a suite, which is a little bit redundant, is a collection of R packages which they're all designed to operate together. So you can use any one of them separate from the others and derive your own study package from it. But the Hades packages unify the workflow that goes from cohort through to characterization, diagnostics, quality control, and then advanced analytics as well. The Hades, the development of the Hades tools has been ongoing for several years and is capable of supporting any size data set, as long as you've got the computational power in your R environment. And its various outputs are, things like your table one as a CSV, or you can have it output, have the suite of tools output interactive dashboards for you to explore your data, create advanced figures. And the great thing about Hades is it's all open source development. So you can chat with the people who are contributing to and maintaining the code. You can propose your own additions and have a full software development dialogue with the invested stakeholders of Hades to bring in changes or optimizations as you would see fit. So the range of packages that exist as part of Hades very much mirror what James has just demonstrated to you from Atlas. There are tools in it for concept set assembly, cohort generation as well. But there are also some other features which are accessible only through taking the scary matrix code approach to performing your study. You can conduct the quality assurance and more programmatic generation of cohorts. For example, if you needed to produce several hundred cohorts to define different subpopulations of prostate cancer patients, you may find that a laborious task to sit and do on Atlas, unless you're going to assign a PhD student to do it. However, if you use the suite inside of R, then you can use it programmatically. You can generate your cohorts quickly that way and in a hands-off and reproducible way. Obviously, it depends on where your data is stored as to how you would interact with it. So Hades was designed from the get-go with translation features as a core part of it. And this allows it to operate on a very wide range at this point of database management systems, everything from Oracle to Spark and Snowflake and pretty much every other flavor you can imagine in between. And even if it's not currently officially supported, you'll probably find someone else in the community that would like it to be supported, and being a community-led project, more voices make more work. And the Hades stack as well has developed quite advanced methods for dealing with extremely large scale analysis. So some of the approaches for things like comparative effectiveness and population level prediction can involve sort of terabytes of data being compared against other terabytes of data. Hades has integrated into its operating modality packages to support that. So that can be things like Andromeda, which is quite a common feature to see in other R packages now, originated within Hades, as well as Cyclops for conducting these comparisons in a highly parallelized way, so that you're not waiting for the traditional R computation approach of one operation, then the next operation. So Hades, as a entity, as a thing produced by the Odyssey community, was inspired by the work that came before it. Bioconductor is a big one, and following on from the great example in Bioconductor, Hades has now been featured in several high-impact publications, and it's not stagnant. So even though it's been used for publications in the past, they are continually developing new releases, new updates to improve, optimize, and enhance the tool stack as it currently is. One of the large ones at the moment, the upcoming development projects, is an operation to modularize the entire Hades stack so that you wouldn't necessarily have to run it directly from within an R instance, because obviously it's largely written in R. But if the approach was modularized, then it would allow for invocation of a Hades execution without needing to actually fire up an R instance. So the areas that have been covered by Hades, or the packages that form part of it, we've got evidence quality measures. So following on with the Greek mythology naming system, there's Achilles, which is a data profiling tool. You run that against your CDM, and that's what populates a number of tables that Atlas actually relies upon. There's a data quality dashboard for checking how your ETL has been performed, whether or not your populations make sense. So this checks for things like events happening before people are born, or events happening after people have died, or people having conditions for non-plausible periods of time. Largely, it makes sure that you are compliant with the CDM spec, and it's fairly important that any study be conducted against something where you can be confident that it actually complies with the specification. There are a great many tools inside Hades for both constructing and evaluating cohorts. So some of them are straight, essentially, are in our copies of the cohort building tool that James has just demonstrated, where you can instruct it to assemble code lists and then create the cohort logic using those code lists inside an R operation. But these on their own will just be R object specifications. They won't be substantiated into your database. For that, there are a couple of supporting packages that are used, some of them based in Java, but the most important one would be Cohort Generator, which allows you to ensure that every time you have a cohort generated for your study, it is produced in exactly the same way, with the same tables, the same outputs. So even if I run it on my data and you run it on your data, we know that the cohorts we get, whilst they'll have different people in them, will have the same rules applied to them. And then we have things like cohort diagnostics, which starts to bridge the gap into the characterization space, where it will analyze the cohorts that you've created, look at the concepts which have been included within that and the demographics of the people that are displaying these, so you can quickly interrogate what population you have actually captured using your cohort and see at a glance what features you are seeing inside that. When we get to the advanced analytics, such as the PLE, patient level prediction, and the supporting packages, these are very much tools that build upon the progress of the aforementioned tools. So without having defined cohorts and controlled code lists, without having the details about the population that cohort has captured, it would be very difficult to estimate the effect of a drug, because you wouldn't be able to match the propensities of a population or predict what features, or use the features in common for predicting the outcomes that you might observe. Particularly the prediction space, this does include a lot of sort of Python callout as well. So you can be assured that it's on the cutting edge of what is possible within the machine learning spaces. Atlas is indeed related with Hades. So if Atlas is your beautiful graphical user interface that serves as the window into your data, then Hades is the house in which that window is installed, and is where you can keep the rest of the data. Without having the tools that exist within Hades, a lot of the tools that exist within Atlas wouldn't exist. There's only so much you can do from JavaScript when it comes to advanced analytics. So as I say, the Atlas platform does leverage what's known as the Hades container, or was previously known as the Odyssey methods library, as its engine. So I've mentioned that Hades provides you with a way to go from a database and create an outcome, a fantastic display and figures that you can analyze and look at your populations. So here I've specified a couple of the packages that could be used for defining population entirely within Hades. It is entirely possible to generate these cohorts using Atlas instead and export them from there. Take the JSON from there and include it into your R package. They all rely on the same standardized framework to instruct the execution of these cohorts. So anything that you do in Atlas can be transferred one for one into the foundations of a Hades pipeline. So once you've got some cohorts generated, you can designed, and the JSON generated, either from R or from Atlas, you can then use the packages within R to substantiate those cohorts against your database, and it will handle all of the steps of identifying the populations, searching all of the various different tables. Again, because of the standardized format, you can be sure that the joins are the joins that it should be doing. It generates all of the same cohort level description tables as Atlas does. It's the same process. You would then choose your more advanced, your further analysis package of choice. So in this example here, I've got a cohort diagnostics. The cohort diagnostics will then ingest those cohorts and run a battery of inbuilt analyses, ranging from reporting the index events, the concepts that are included inside your code lists, and the details about the population as well. And it will also demonstrate if there are overlaps in between your cohorts. Perhaps that's desired, perhaps that's not desired, perhaps you've got something that cross-pollinates between two cohorts. These tools will very quickly demonstrate to you what that is. once the cohort diagnostics package has run, it creates a series of CSV files and a little database that stores all of your results. So it's a fire and forget kind of operation. And it produces at the end of it a sort of standardized shiny dashboard. And I've got a couple of examples of those I'll show you shortly. So just to summarize the workflow that would typically go into running any Hades package, you input a collection of cohorts and phenotypes, algorithms that you've designed to capture the populations that you care about in the ways that you need them to be. You can process them using one of the Odyssey packages, which will provide you with breakdowns of their index events, characteristics, and allow you to match your populations. And then you can get your detailed outputs all from within the same suite of packages. So I will just quickly swap over now to some examples. So this is one of the shiny dashboards that I've mentioned, specifically the shiny dashboard for what is referred to in Odyssey as the phenotype library. This is a series of cohorts that have been designed by the community.
Sorry, I think you're still on the PowerPoint. At least that's what I can see.
You are indeed correct. I thought I was sharing the screen rather than the... Hold on, please. Here. My apologies.
Yeah, all good.
There we go. That looks better. So this is one of the shiny apps that I was discussing. Specifically a cohort diagnostics that has been conducted on the phenotype library, which was a community effort by Odyssey to sort of designate clinically acceptable and peer-reviewed phenotypes of various different disease areas. How many, you ask? In excess of 500 at the moment. I've selected one of them here, which is in line with what James was demonstrating, a prostate cancer diagnosis. And to circle back to where James started, you can see here the lists of concepts and the count of the persons for a given database. All of the different concepts that appear for this cohort on this database and how many people have it. There are a lot of different tabs here, so I'll go over a few of them. So there's a cohort characterization. This is a sort of a basic cohort characterization, but it still brings in a great deal of it should still bring in a great deal of useful insights. Or it would have, that one worked. Which would show you things like the comorbidities, the Charlson comorbidity score for each substrata. And it also allows you to look at comparisons between cohorts. So if I fetch back our prostate cancer cohort, we can see, for example, in this overlap tab, what the interaction is between the various cohorts that we have selected here. So you can see whether or not you have a link between your events. For those of you of a more coding focused approach, this is the sort of thing that these R scripts look like. So in this example here, this is a study that was previously run by Odyssey. The code is available on GitHub for you to download and run at your leisure if you have a CDM. And you're usually just presented with the one script that you have to put variables into and an execute argument, which will produce your outputs after some processing time. Then there's areas where it will save your data to, and in the end you get an evidence explorer, which again is another shiny dashboard. And this is a slightly different one because this was a patient level prediction study, but it gives you a number of the measurements and important statistics about your populations. So if we look at the propensity models, you can see all of the covariates and the weightings that were applied to them, the propensity scoring to show you how close the populations were after balancing, and then how the covariates were adjusted as well are all reported within this. So as you can see, with the Hades stack, which again underpins Atlas and goes all the way through to these advanced outputs, it is your journey from initial ideation of a research objective, creation of your populations, and through to your final outputs. So with that, I think I've gone a couple of minutes over, but do we have any questions about the journey through Hades?
Thank you very much. Thank you very much, Jack. Yes, I'm still recovering from all these wonderful classical illusions. I guess I'm still, I can see that they are in some sense parallel, Atlas and Hades. You did explain that a little bit in response to Pantelis's question. Maybe you could just say that again. When would you use one or the other? What typically would be the scenarios?
Sure. So, and James may disagree with me here. I would say you would use Atlas in the beginning. You would use Atlas when you are first learning how to define Odyssey cohorts, when you want to visually grapple with the logic and order of operations, and when you need to quickly, very quickly, come up with an idea of what you might be looking for or at. I would say that Hades, the more in-depth approach to doing all of the above, and at larger scale. So if you're using Hades, then you are approaching your logic in a more detailed way. You have to code it out, and you're feeding it into these advanced analytics packages, which you can do more with than you can with the Atlas interface. One big advantage of running things inside of Hades versus running it as an Atlas approach is you can interact with the objects along their journey. So, for example, if you have a cohort that you can define in Atlas just fine, but you have a very specific non-OMOP criteria that you have to apply, for example, you need to check, I don't know, what the adherence is to a particular drug, and the measure that you need to use for it is contained within like the source drug name instead of the day's supply. Then you can do that by applying an additional SQL script from the R environment during your generation, during your journey in the R package. And if you look at the Odyssey studies that have been conducted in the past, you'll see this all over the place. People have added in their own little bits of SQL to refine what you can get straight out of the box, or to combine things in interesting ways, or to attach in extra tables that aren't Odyssey standard and therefore Atlas can't see. So really, it's the flexibility and complexity that Hades provides for the advanced analytics and for answering even deeper questions than you can with Atlas.
I shall remember that by Hades being the place you go to if you want to go into the deep detail, into the depths.
Quite exactly.
Sorry, James, I spoke over you.
No, I think I spoke over you. No, I would second what Jack is saying. I do take a slightly different approach, Jack. I think I still use the cohort functionality exhaustively, even after doing this for 3 years now. But the sort of characterization tools within Atlas, you do tend to take the cohorts that you define, and instead you use other tools within Hades or bespoke SQL to that. But for me, my sort of working philosophy is, as best you can, find the cohort in Atlas and then take it out. With one exception, which is the population level estimation, which Atlas is very good for. You still have to run that in R, but as a framework, it's very useful.
Brilliant. Thank you. We are nearly at the hour, I think, and I'm going to suggest we wrap up. Will, if in a minute, I'll ask you just to remind people about the SharePoint, but just to say, firstly, thank you very much to our presenters. Once again, I haven't got all the detail, but what's clear to me is the extent of the work that's already been done out there that we can draw on. So that was great to see. It was lovely to see some practical examples. Also, please do ask questions. Come to the training email address if there's something you want to know more about. We can put you in the right direction. And that's it from me. Will, any final messages from you just around SharePoint and next steps?
Yeah, just to say, I mean, permissions on SharePoint can be a little bit, take a little bit of time. If you've not tried to access the SharePoint, please do. And if you could get back to us if you've not done it, I can just share my screen quickly. This is what you should be able to see when you go on the SharePoint. I'll include the link again in an email about this session that'll come to you all tomorrow. But here on the course materials page, you'll have the recordings of each of the sessions. You've got the slides in PDF and any further reading as well that might have been mentioned. Two webinars. The third webinar will be soon added to this. But the SharePoint will become increasingly useful where we start to design studies. So if you haven't tried getting on, please try and access. The invite should have come. You should have the permission to. If you can't, get in touch, and there might be a bit of to and fro. If you've already tried and you've not been able to get on, please let me know. And if you're on, please let me know, just to get an idea of how many people have managed to access the SharePoint at this stage. We'll continue to use it. The information on it will continue to grow, so it'd be good to make sure that you're all able to access it as early as possible. Thanks.
Great. All right. Well, thank you once again to our presenters. Thank you, Will, and thank you everyone for attending today. The next seminar is on patient involvement in real-world research. That's on Tuesday, the 21st of May. So just under 2 weeks off. So have a great time till then. Thank you very much. Cheerio.